Alright, so today we're going to extend our conversation to the distributive property a little bit. And remember, the distributive property is shown here as two factors, factor A times the factor B plus C. Again, that's one thing. And when I distribute A times B and A times C, I get AB plus AC. And I take something that's one product with two factors to a term, or algebraic expression with two terms. And I don't want you to freak over fractions. It doesn't change anything in this problem when I write x divided by y times the quantity x over z minus y. It's still A times B and A times C. It's still the outside times the inside. And I can show that in this manner. And there's the same problem. X over y times the quantity x over z minus y. One thing here and one thing here. It's a product at the moment. Two factors. I see this as A, where A is x over y. I see B as x over z. I leave the minus in between, and I see y as c. And I know this is AB minus AC. So simply over here I wrote what I said. Each variable, A, B, and C, is equivalent to the term above it, or the algebraic expression above it. And I want A times B, and I want A times C. Well, A is x of y, B is x over z. Multiply them, xx over yz, x squared over yz. AC is x over y times y over 1. And sometimes putting the 1 in the denominator helps to see these multiplications. So x times y is xy, y times 1 is 1y. Now this is one thing, because it's x times y are both factors, 1 times y are both factors. So when there's both factors, we can simplify by canceling the y's, and I get x. Then I add AB minus AC, so x squared over yz minus x. I wouldn't suggest you write all this out. I just want you to see that this is the way it works. What I suggest, when you see fractions, besides not freaking, is to distribute. And I write the outside term against the inside term. xy times xc, shown here. xy times y. The sign stays the same. And then I simplify each term individually. I simplify this term and this term to the final answer. Now, if you want to try an example, and I can cover it up here for a second, you can do the example up here. Pause the video. Now, all we do is the same thing. The outside, this one thing, multiplies inside. 3x squared over y squared, the first, times the inside, 2x squared y. Sign comes down. The outside, 3x squared over y squared, times the inside, 4y cubed over m. And then I simplify each individual term. 3 times 2 is 6, x squared is x to the fourth. Y squared y, 3y, so y cubed. In the other term, 3 times 4 is 12, x squared y cubed on top. On the bottom, y squared m, right amount. And again, one group of factors, 3 y's on top, 2 y's on the bottom. I can cancel those since they're factors. And I get 12x squared y over m. Notice two things. These are not like terms. X to the fourth is not the same as x squared. Thus, I cannot take 6 minus 12 for negative 6. Cannot do it. They're not like terms. They're cats and dogs. Hearts and spades, diamonds and clubs. They're just not the same. The other thing you got to catch is I am not taking the y and canceling across. You have to look at each term separately for cancellation. And you got to go slowly with this. And again, distributing with algebraic fractions, just have to go a little slower and be a little more careful and try to watch your exponent rules.